Hi guys, I'm Dheeraj. I'm going to take one important problem and one of the great problem in this time in GATE examination has been asked. Okay, so let us take a look on this problem and read the problem first. Okay, and the subject is VLSI design. We can say okay. So in the circuit shown, V1 equal to 0 and V2 equal to VDD. Okay, and the other relevant parameters are mentioned in the figure. Okay, ignoring the effect of channel length modulation and the body effect. Okay, the value of I out is okay in milliampere. You have to answer and round it off to 1 decimal places. Okay, so let us take a look in the circuit. Okay, and this question can be solved by inspection. Okay, within in fact 2 minutes. Okay, but I'm gonna explain you how to find this current I out. Okay, here. So let us see how we're gonna approach this problem. Okay, so you can see here by looking at this circuit, you would be able to identify this is current mirror. Okay, this is current mirror, right? So you can see here, if all parameters of these two transistors are getting matched, so whatever current flowing through this transistor, the same current will flow through this transistor. Okay, but you can see here the aspect ratio here is 2, and for this transistor aspect ratio is 3. I mean to say W by L is 3. Okay, so we can say that the current flowing through this transistor would be different. Okay, and how, by what amount it will be different, we can say, we know that ID equal to half mu1 COX W by L VGS minus VT whole square. Okay, so here we can say our ID is directly proportional to W by L. Okay, directly proportional to W by L. Okay, directly proportional to W by L. So whatever current here it is flowing, like we can say this is ID1. Okay, so what shall be ID2? So we can find ID2 here by C. You know that ID is directly proportional to W by L. So if we are finding ID2 here, ID2 here, so it will be ID1 times of W by L 2, means this is W by L 2. Okay, so we can say 3 upon this is 2. Okay, so it will be 2. So we can say here ID1 is 1 milliampere. So 1 milliampere into 1.5. So it will be 1.5 milliampere. Okay. So here we can say at this point the current ID2 is flowing. Okay, is 1.5 milliampere. Okay. And by looking at above circuit, okay, see you can say that this is source terminal. If we are going to identify the terminals here, and this is gate terminal, this is drain. Okay, and this is again the source, the gate and the drain. And when gate and drain are sorted, in case of PMOS, they are always in SAT. So we can say they are always in SAT, saturation mode. Okay, they are always in SAT. So here the current will flow, okay, from this transistor. But you can understand, you can see the main point where you have to be very cautious is that they have given V1 equal to 0 and V2 equal to VDD. Okay, this is the point where we always mistake, because just we always approach blindly. We don't read the question just by looking at the circuit. Okay, and we'll get the different answer. Okay, so read the question very carefully, whatever information they have given, and utilize them carefully and find the right answer. Okay, so here Vi is 0 means this transistor is off, always off. Okay, because already they have given Vi is 0. So whatever current through this transistor is flowing, it cannot be. Okay, so we can say that current will not flow. Okay, so here ID is 0. Okay, and this current is, okay, it is coming from here to here. Okay, from these two transistors. Okay, from here whatever current is flowing, and from here whatever current is flowing. So you can see here this transistor will be off always and this transistor will be on. So 1.5 milliampere will be hogged by this. Okay, entire current will flow from this part of the circuit. Okay, so we can say here current is flowing 1.5 milliampere only. Okay, so again you can see here this current will be how much. Okay, again we can say if it is flowing 1.5, so I out will be how much? We can say this is ID1 and this is ID2. Okay, again you can see WIL ratio is 10 here and WIL ratio is 40. Okay, so we can say here it will be 1.5 milliampere into this. Okay, WIL is 40 upon 10, so 10 0 gone, so it will be 1.5 into 4. So what will be the multiplication? 15 4 ja 60. Okay, so it will be 6 milliampere. Okay, so answer will be 6 milliampere. Okay, so you can see here we are solving this question by inspection. Okay, if you know simple relationship, ID is proportional to WIL, and if you know the parameter here, how you can relate your current with WIL ratio, and if you are able to identify the circuit here, the circuit given is current mirror circuit, you know, one of the versatile, you know, current source. Okay, and then only you would be able to solve this problem. Okay, and please read the question very carefully. Here they have mentioned given is 0, so this transfer will be off, so no current will flow from this part of the circuit. Okay, and entire current 1.5 will flow from this circuit. Okay, and again, you know, ID is proportional to WIL ratio. Okay, and you would be able to answer this question. Okay, so here 6 milliampere is the right answer. Okay, so please share this video among your friends and come to know how to find anything by inspection. So thank you so much.